Hello, welcome to Maths with EJD. In this video, still on linear programming, we'll be considering a very important method called simplex method. So, the simplex method is an algorithm developed by George Danzig in the 1940s for solving linear programming problems, which are mathematical models that aim to maximize or minimize a linear objective function subject to subject to a set of linear constraints. The method is particularly powerful particularly powerful due to its efficiency in navigating feasible solutions in high dimensional spaces. Course, if you've been following this series on linear programming, you know we've already talked about graphical method for solving linear programming problems, right? But then graphical methods are restricted to when you have just two variables. But when you have more than two variables, it becomes a problem. And that there comes simplex method. So method can take care of problems, whether you have two variables, three, four, and so on and so forth. That's why we say it's very good for high dimensional spaces. So linear programming is widely applied in various fields. For instance, we've seen examples in healthcare, we've seen examples in manufacturing, and there are so many other areas where you can still apply linear programming. So linear programming is widely applied in various fields such as economics, engineering, military operations, and transportation, making the simplex method a crucial tool for optimization in these areas. Okay, so let's look at an overview of the simplex method. So the simplex method operates on the principle of moving along the edges of the feasible region. Okay, I mean, this bears a bit of resemblance with what we do in graphical method. Graphical method, once you plot all the lines and you shade the required regions, then the corners are really, then you begin to check for the corner points to see which of them is a minimum or maximum depending on what you're looking for. So the simplex method operates on the same principle, about the same principle, right, of moving along the edges of the feasible region. Okay, defined defined by the constraints to find the optimal vertex, or what you can call the corner point, where the objective function achieves its best value. The process begins with a feasible solution often found through a phase called through a phase called initialization phase. The method iteratively improves the current solution by performing pivot operations, which involve swapping basic and non-basic variables. So you swap basic and non-basic variables to explore adjacent vertices of the feasible region. Each iteration moves the solution closer to the optimal point, while ensuring that all constraints are satisfied. based on this explanation alone, you can agree with me that if you have two variables, the best way to still go is the graphical method. But I mean, since method cannot handle three variables upwards, then you can consider this. But of course, definitely you can still use this method for two variable problems. So let's look at some steps in the, or should you say key steps in the simplex method. So number one is you have to formulate the problem, of course, which we are already used to, right? Formulation of the problem, definitely a linear programming problem. So you have to, but of course, beyond the formulation, right? You have to convert the linear programming problem into a standard form. So in a moment, I'll be talking about the standard form and all that, into a standard form, ensuring all constraints are expressed as equalities with non-negative variables. So, for graphical method, right, all we do is you start with the constraints and, convert them into lines for plotting, but then you still need the inequalities to know the regions to shade or not. Two, we talk about identification of the initial basic feasible solution. Okay. This is often done by introducing slack variables to transform inequalities into equalities. Okay, so by this transformation, then you can see the variables to set to zero, and then you call the slack or so the initial basic feasible solution and all that, as we're going to see in one or two videos after now. So we talk about the iterative improvement. Iterative improvement. So use the tableau, use the tableau method, use the tableau method. So a tableau is simply a table. Use the tableau method to perform pivot operations and update the basic feasible solution until no further improvements can be made, indicating the absence of positive coefficients. in the objective row of the tableau. Then the fourth key step will be about the optimality check. Of course, we have hinted a bit on that in the step 3, but let's see clearly here. Optimality check. Once the objective function cannot be improved further, the current solution represents the optimal solution to the LP problem. And one indicator of no further improvement will be about is this absence of positive coefficients in the objective row of the tableau. You're going to see that when we get there. Okay, so with that said, we can go back. We can go to another thing, which is about the importance of high dimension linear programming problems. So when we say high dimension, we're talking about like 3 variables upwards. So let's look at the importance of higher dimension linear programming problems. So the significance of the simplex method becomes especially apparent when dealing with higher dimensional LP problems, higher dimensional linear programming problems, where the feasible region, can be complex and difficult to visualize. Things are easy to visualize if you're dealing with just 2 variables, like I've said, and that's where you can use graphical method. But in this case, if you have 3 variables upwards, you won't be able to do that. So simplex method becomes really important. So in high dimensions now, in high dimensions, the number of potential solutions grows exponentially. Grows exponentially, making exhaustive search methods impractical. I mean, the idea here is that, for graphical method, right, you get all the corners. By the time you draw all the constraints and you have shaded the required regions, so you now get all the corners. So most of the times you get like 3, 4, 5 corners, and then you evaluate that on the objective function and you get the either the maximum or the minimum depending on what you're looking for. But when you come to once you have three variables, four variables upwards, that becomes so many that trying to check each one out one after the other can be really can be such a big problem. So simplex method really helps to take care of that trouble. So making exhaustive search methods impractical. Uh, yeah. So in high dimensions, the number of potential solutions uh, grows exponentially, making exhaustive search methods impractical. Then, so the simplex method effectively reduces this complexity by focusing only on the vertices of the feasible region, significantly improving computational efficiency. Okay. So its ability, its ability to handle large scale LP problems makes it a fundamental algorithm in optimization with applications ranging from resource allocation, resource allocation, uh, to network flows, to network flows and beyond. Okay. Now, for us to understand to be able to apply simplex method, it is important to understand the linear programming forms. I think I want to stop this video here so I can now do the next video will be about linear programming forms, which is useful. It is important to know these forms for the sake of simplex method. So on this note, let me stop here so I can do linear programming forms so I don't make this video longer than what it is already, especially since I have the ability to split things up. All right, so if you have not subscribed to this channel, be sure to do that right away. And then hit the notification bell so you can always get alerted each time a new video is released. Then after that, make sure you comment. Tell me if you want me to teach a topic or you want me to solve a problem. For instance, I'm teaching linear programming because a friend of mine is doing a course in it and he would like to get he would like to really understand it, and that's why I'm doing it. So I can do the same for you, especially if the time is right. So try to comment and let me know. Then like also and share so that more people can have access to all this great learning. Till I come your way again, have a very nice time. Bye.